Hello everyone, this is the class of ECE 350, the principles of automatic control. Welcome. Today we will consider the inverse Laplace transform. We already studied about the Laplace transform, the definition, how about the tables, how to use the tables, and then we have some examples. Right? Today we will study something about the inverse Laplace transform. We will go back from transformed function on S, go back to the signal on time. The ECE 350. This is second week Friday's class. Okay. You consider the inverse Laplace transform. Okay, I just use some examples to explain the method. Alright. Example 1. We consider the g of t, a signal g of t with a Laplace transform g of s, which is 2 plus s over s times s plus 1. Okay. Then what is the inverse Laplace transform? Find the inverse Laplace transform of g of s. Okay, how to solve it? We start from g of s. We want to go back to time domain, and basically we need to use the tables. So first of all, you can check the table, Laplace table. I open it here. Okay, we want to find, do we have, you see this is some numerator over denominator. Denominator is s times s plus alpha. Okay, we find it at here. But this is not exactly as same as others. Oh, I can't. Sorry, can it? It's a. Oh, I never found this software is not so friendly. It have to occupy the whole screen. Anyway, let me copy this in my notes. All right. So 1 over s plus alpha. Then by inverse Laplace transform will be 1 over alpha times 1 minus e to the negative alpha t. Okay, it's in my notes now. Yeah, I copied it here. Then you see this one and this one not exactly the same, because the numerator now I have two terms. Here's one term, so I can write these as a summation of two terms. That is 2 over s times s plus 1 and plus s over s times s plus 1. And then you see s and s can be cancelled. Alright, first term I can use these, and the second term we have another one, s plus alpha. By inverse Laplace transform there will be a e to the negative alpha t. This is also a term in the table, so we can use these two to get an answer. We have the inverse Laplace transform. Perform inverse, I get g of t, which is 2 times this part, right? So 2 times, now alpha is what? Alpha is a pole. Is not pole. Negative alpha is a pole. Is number follow the s, right? After s, so this is 1. Alpha is 1. So it's 1 over 1 times 1 minus e to the negative 1 times t, and plus this is e to the negative 1 times t. So let me do some simplify. 1 just 1, and 2 times in it I get 2, and minus 2 of e to negative t plus e to the negative t. So totally I have 2 minus e to the negative t. So this is our answer. Alright. Yeah. And of course, if you want, you need to put t positive. positive. In negative side, we don't know what it is. Now maybe you want to make sure that side is 0. Negative side is 0. You can also write it as 2 minus e to negative t times us of t. Because us of t, positive side it is 1. Negative side is 0. So these two times together. Then the positive side is as same as these, and the negative side is 0. Okay, either way works. Alright, this is first example. It's quite simple, right? Now let me make some change on this example. Example 2, g of s is 2 plus s over s and s plus 1, but I have one more term, s plus 2, 3, okay. One more term. Then we can check the table. This time, actually we do not have 3 factors in the denominator, you see, in our table. Maybe you can find some other tables online, other tables online where they contain fractions with 3 factors in the denominator. But here we do not have. This is the table from our textbook. We do not have 3 factors in the denominator. So in this case, we need to do some simplify so that this fraction just have like 1 or 2 factors in the denominator. Actually, we can have just with 1 factor in each denominator. We write this as a summation of some terms, like similar like this, right? I separated as 2 parts. Right? In example 1, I separated the whole g of s as 2 parts. Each part is simple and can be applied in the table. Now we do the similar thing, but we need more calculations. So this is a method we call it a partial fraction method. Partial fraction method. We suppose, now it is just a suppose. Suppose this one equal to some a over s plus b over s plus 1 and c over s plus 2. 3 terms. Each factor, you see, we have 3 factors in the denominator. Then each factor related with 1 term. And with some coefficient, we do not know what are these coefficients. So here I say it's a suppose. We suppose we have these. And now we need to find these constant a, b, c. If we can determine this a, b, c, then these 3 terms we can have the Laplace transform, right? I put it here. 1 over s by inverse Laplace transform, it is 1 or us of t. Right? This is for t positive. Right? So this one I use this, and the other 2 terms I use this. Okay, now the problem is how to determine a, b, c. We know, you see, this whole fraction equal to the summation of these 3 fractions. So this one equal to this one. I have 2 plus s over s plus 1, s plus 3 equal to a over s plus b over s plus 1 and c over s plus, this is 3. Third term is s plus 3. We have this one. Now times s plus 1, s plus 3 on both sides. Right? We times this one, this part. I times this part on both sides. Then this equation will turn to be equation just for polynomials, not for fractions. Right? Fraction is hard to handle. So we make some change. Then we get equation on polynomials. Okay, after times this on the left side, the denominator is cancelled. This denominator is cancelled by this one. So I have s plus 2 plus s equal to, okay, I use this one times first one. First term is a over s. A over s times this, the s will be cancelled, and we have a times s plus 1 and s plus 3. And the second term, b, s, then s plus 1 cancel. I have s plus 3. And then c, s plus 1, s plus s and s plus 1. S plus 3 cancel. Alright, now we have this. This is the equation on polynomials, right? Yeah. Now we can do calculation. Because here's a function, right? Both sides are a function of s, so we can choose any value of s. Let s equal to, you can pick any value here. Then you will have an equation just on a, b, c without s. Right? You will replace s by some value, some constant. Now which value is good? You see, I have s, so if I choose s equal to 0, then these two terms will be vanished, no values, right? So let s equal to 0, then we have 2 plus 0 is 2, equal to a times 0 plus 1, 0 plus 3, so here's 1 times 3, I guess 3a. And b term, we have s, it's 0. C term, we have s, it's also 0. Then we can have a equal to what? 2 over 3. Now we determine a, right? Okay, so this is a way quite simple, right? We can do similar thing for those b and c. Now let s equal to some different value, not 0. Which value is good? Okay, we want to determine b, so we want these two terms turn to be 0. So you see both contain s plus 1. Then we can use s equal to -1. Okay, then we can have s is -1 here. I get 2 minus 1, it is 1. Equal to s is -1, this is 0, so 0. S is 1, s is -1, so b times -1 times -1 plus 3, that is 2. And plus c, s and s plus 1. S plus 1 is 0. This is 0. Okay, then we have b is what? Is 1 over, this constant is -2, right? Over -2. Over -2. Yeah, we prefer writing this way. -1 over 2. Okay, this is b. And then last one, we want to know what is c. So we can try to pick some value, make these two equal to 0. Which one? S equal to 3, -3, right? Both will be 0. So s equal to -3 will give us -3 and 2, I have -1. -3, this is 0. -3, here's 0. And the -3, okay, c times -3 and -2. Okay, -2. Okay, then we have c equal to -1 over 6, right? Negative is positive, positive 6. Okay, now we have a, b, c. Then we can determine. So we know g of s equal to a is what? A is 2 over 3. A over s. So this is 2 over 3 over s plus b is negative, minus 1 over 2 over b is s plus 1. And plus c is also negative, minus 1 over 6 s plus 3. Okay, c is also negative. Okay, now we can write what is the inverse Laplace transform. This is a 2 over 3 times 1 over s, which is the us of t, or just 1, and minus 1 over 2 e to the negative t, and minus 1/6 e to the negative 3t. That's it. If you want, you put t positive. Right. So this is the answer. This is the answer. This is the g of t or equal to this one. g of t equal to this one. Alright. I think you already know these methods in some early courses, right? Yeah, it's kind of review. Okay, this is the second example. I use this one. I use this one. Okay, now we consider more complex cases. Example 3. G of s equal to 2 plus s, same numerator. Denominator I have s plus 1, s plus 3, but I need a power in some of these terms. For example, I put 3 here. I have power 3 here. Then what can we do? Okay, we still use the partial fraction method. Suppose, yeah, we want to find the g of t, right? G of t. What is g of t? Suppose g of s. Now we need some a over s, right? Some simple fractions with unknown factors, unknown parameters. A over s, b over s plus 1, and okay, here s plus 3 with power 3. Then you need how many? You need 3 terms for these. Yeah, this is 3 terms, not just 1 term, right? You have s plus 3, 3 of s plus 3. Each factor you have 1 term. So here's the 3 factors. You need 3 terms. Now where can you find the 3 terms? This one, of course, this will be a term. This will be a term, s over s plus 3. Then how to get the other 2 terms? Okay, we can just add powers on it. Say d over s plus 3 squared and e over s plus 3 cubed. That's it. Now we have 3 terms. We have 3 terms. Alright. Okay. Then times s plus 1, s plus 3 cubed on both sides. We can have this side, you times the whole denominator, you get only the numerator left, right? Alright, equal to this one times a over s. The s cancel. You have a s plus 1, s plus 3 cubed. Yeah, here you need to be careful because these powers, so make things not exactly as same as previous examples. Okay, the second term, this one times b, I get b times s plus 1 cancel, right? S and s plus 3 cubed. And the c, now is s plus 3 cancel only 1, right? I have 3 here. The power is 3 here. You will cancel 1 of it. So you have another 2 left. Square. Here's a square. It's a c term. And the d term, similar, but now you will cancel 2 of it, right? So I have d times s, s plus 1, s plus 3. You cancel 2, 1 left. Yeah. And the last term e. Now is a cube. All the s plus 3 terms cancelled. All 3 will be cancelled, right? So we have e times s and s plus 1. Alright. Now let s equal to similar, you can think like s equal to 0. Then all these terms with s, they will turn to be 0, and only a terms left, right? So I get 2 plus 0 equal to a times 1 times 3 cubed, and all the rest part are zeros. Then we can have a equal to 3 cubed. 3 cubed is a 27, right? 3 is 9, and times another 3, 27. So this is a 2 over 27. This is a. And let, okay, a is done. Then we try to vanish the rest part. S equal to 0 we use. And another possible choice are s equal to -1 and s equal to -3. So we try s equal to -1 first. S equal to -1, we have 2 minus 1 is 1, equal to as plus 1, you get 0. And the b, okay, we have b times -1 and -1 plus 3q. And c with s plus 1, d with s plus 1, e with s plus 1. So okay, all of the rest are zeros. Then we can have b. b will be 1 over, this is 2. 2 cubed is 8, -8. 1 over -8 is a -1/8. Right? So this is b. This is b. Then, okay, we have used 0, -1, then use -3. Right? Let s equal to -3. 2 minus 3, I got -1, equal to, this is -3, you got 0. -3, you got 0. -3, you got 0. -3, you got 0. Okay, only the last term. E times s equal to -3, and s is -3 plus 1 is -2. Okay, then we have e equal to -1 over +6. This is the e. Okay, we have a, b, e. Now we still need c and d. But here, those simple values, good values, we already used, right? 0, -1, -3, 0, 0, -1, -3. They can make some terms to be 0, but we already used. We still have 2 unknowns, so we need to pick some different values to determine c and d. Okay, then you can choose any value. Yeah, whatever, and we can try to use some value which will be, smaller. That will be simple, right? Now let s equal to, I have 0, -1, then choose +1, for example. Then I have s plus 1, I have 3, equal to, now we need all of them. We cannot erase anyone. A times s plus 1 is 2, s plus 3 is 4 cubed, and b times s is 1, s plus 3 is 4, and c is s is 1, s plus 1 is 2, and s plus 3 is 4 squared, and plus d times s is 1, s plus 1 is 2, s plus 3 is 4, and e times s is 1, s plus 1 is 2. This is quite long. Then be careful. What are these? 3 equal to, okay, 4 to the cube. What's that? 4 is 16 times another 4, 64, right? 64, 32, 64. So this is a 64. 4 to the cube is a cube of 4 is 64. Times 2 is 128 times a. And the b is just 64, right? 64b. And c is now square. Square is 16. 16 times 2 is 32. 32c. And the d is 8d, and a is 2e. We have long. Then we can add the values because we already know a and the b and the e, so we can plug in. I have 3 equal to a is okay, that will be 256 over 27, and the b is negative 1/8. So 64 divided by 8, so another 8, right? No, positive. 64 over 8, I get it. 8, right? the 8 cancel. Negative 8. And plus C, we don't know what is C. And the D, we don't know what is D. And 2E, the minus, E is negative. Times 2, I get negative 1 over 3. Okay, we have one equation which contain C and D. Contain C and D. But you know, this is one equation with 2 unknowns, so it's not enough. We need another equation with these 2 unknowns. Now let S equal to, yeah, positive seems make this large. I use negative 2. Okay, negative 2. Negative 2. I have, oh, this is 0. Negative 2. This is 0. 0 equal to A times negative 2. This is negative 1. Negative 2, I get 1 cube. This is simple. And B times negative 2. Negative 2, I get 1 cube. And C times negative 2, negative 1, and 1 square. And the D, S is negative 2, negative 1, and plus 1. And plus 3, I get positive 1. And the E times S, negative 2, and negative 1. Okay. Now here is a 0 equal to A with coefficient just negative A, right? Negative 1. And this is a negative 2. This is a negative to positive 2C. And okay, this is also positive 2D. And positive 2E. Okay, and let's put the value in. What is A? A is 2 over 27, and B is negative 1/8 times 2. I get negative 1/4 plus 2C plus 2D, and E. E is negative 1/6 times 2 is negative 1/3. Okay, I have second equation. Now I have 2 equations. Now the problem is how to solve these 2. Let me put them in a linear equation. Usually we can put it like this. I put 32C plus 8D in one side and all the constant to the other side. The constant I already have is 3, and move this to the other side will be negative 256 over 27, and this will be plus 8. This is a plus 1/3. It's a long one. And this one is 2C plus 2D equal to, okay, this is 0, just 0, nothing. Then this one move to the other side will be positive 2 over 27, then positive 1/4, and positive 1/3. Okay. Well, this example is not so good. We need this part. We need a big calculation. What it is? I put them together, just 37, right? 27. So 27. Here is 3 times 27 minus 256 and plus 8. Okay, I put these 2 together. That'd be 11, right? 11 times 27, and plus this is 3. I need another 9, right? I times 9 times 9. I get 27. 27. So this 2 is 11 times 27. This one. Okay, and this one also use denominator is also 27. 2 plus I have 1/4. Is it correct? 2B. No 3. Okay, so I need times 2 here. Times 4 here. So here's times 4 plus 1 times 27, and plus this one I need a 9 to get 27 and another 4. Okay, so this is 32c plus 8d equal to what it is. This is 27, right? It's a 297, and plus 9, a positive term I put together. So it's 306, and minus 256. 6 cancel. It's 50 over 27. Oh, it's not so bad. And this one is 8 plus 27 plus 36. 6, 7, 8. So it's just 3 7s, right? It's 21. And 2, 5, 7, 1. So this is 2c plus 2d equal to 71 over this is 27 times 4. 27 times 4, 28, and 8, 1 over 8. Oh, still a lot. Then what it is? I can cancel a 2 here, or I can cancel something. Okay, this is a 16, this is a 4, and this is 25. No more. Then this one I times 2 on it. I get 4c plus 4d equal to 142 over 108. Now I can cancel one. This is 71 over 56. Then you see both contain 4d. So I do a subtract. I get 12c. They cancel, right? This is 16 minus 4 is 12c. Equal to, this is 25 over 27 minus 71 over 56. And not 56, 54, sorry. So this times 2, right? This is 50 over 54 minus 71 over 54. So this is 21 over 54, and this is can divide it by 3, right? I get 7, and this by 3 is 1, and 1, 3, I have 3, I need another 2. 24 by 3 is 8. 24 6. 54 divided by 3. 1 is 3. 24. 8. 8, yeah, it's 8. This is a yeah. So it's 18. So it's okay. So 12c equal to 7 over 18. So c equal to 7 over 12 times 18. Yeah, it's a big number. 18 times 12, 36, and 1/8 is 216. 7 over 216. This is c. And the d we can just use this one to get d. D is 1 over 2. Right? 2d is this 71 over 108 minus 7 over 216. Oh, okay. I just leave it. If you want to use calculator, you can find some number, right? You can find some number. All right. Now we have A, B, C, D. Okay. We got A, B, C, D. So we can have G of T is A. What is A? I forgot what is A. Too many calculations. A is here is 2 over 27. 2 over 27. 2 over 27, and A related with S here. A over S. So S is just a constant 1. Or you can put US of T. You put nothing is also fine. And B is 1, negative 1/8. Negative 1/8. Here is over S plus 1 is E to the negative T. And C is, let's see, C is here. C is a 7 over 7/216, and C is the coefficient of s plus 3. S plus 3 is e to the negative 3t. And D is this one is 1/2 times 71/108 minus 7/216. This is D, and D is a coefficient of D over s plus 3 squared. So what it is, we check the table. We have this in the table, s plus a with square, s plus a with square, or I have s, or I have s plus a square. It's here. This one is t times e to the negative alpha t. Okay. T times, okay, I copied it in my notes. 1/s plus alpha square, according to t times e to the negative alpha t. And actually we need a 3, the cube, so we use this one. This is a n factorial over s plus alpha to the power n plus 1, according to t to the n e to the negative alpha t. Okay, I copied this term. I already copied this term in our notes. Yeah, here I copied them here, and now we want to apply it to here's s plus 3 square, s plus 3 square. So alpha is square. Alpha is 3. Alpha is 3. So this is a t times e to the negative 3t. Okay. And another term is e. E is a negative 1/6. Negative 1/6. Negative 1/6 times. Okay. Here's a 1/s plus alpha cube. Cube means here n is 2. N is 2. N is 2. Here we need a 2 factorial here, but we do not have 2 factorial, so I need a divided 2 factorial here. Then I can add a factorial inside that 1 over. Right? Here's a 1/s squared plus 3. So I divided by 2 factorial. Then inside part will be 2 factorial over s plus 3. Here's 2 plus 1. Then I can apply this term. I get a t to the r to the n. Now n is 2, and the e to the negative alpha is 3t. All right, this is a final answer. It's a final answer. It's a very long one, But you know, the thing is, you know how to do it. You know how to do it step by step. So this is not really hard. It is just some complex. You know how to do it, but you need a lot of work on it. And make sure you do not have typo or some calculation wrong. Yeah. Hopefully I do not have errors. Maybe I already have. If you are interested, you can try it by yourself to see whether, okay, professor, you make some mistake. You can try to find it. Maybe I'm good. I think I'm good. Alright. This is a second example. Third example. This is third example. I have a cube here. Then the problem is why this one is so complex. Yeah, it's just because I have this cube here. I have this cube here. Then I have these two terms. These two terms we cannot get them just by a very simple way, right? Here you use some simple value of s. You cannot get this c and d. Then you need to rewrite the equation so that you have some linear equation just constant on c and d. Then try to solve the equation, right? You try to solve the equation. You put these two, yeah? You see, this is a linear equation. You have this one, you have the equation, right? Of course, these kind of things you can also use a computer to do it. What it is, computer or calculator, you can get some number with some not real number, like not fractions. You get some real numbers here, and you can also solve this use the help of MATLAB. Remember how to use MATLAB? to solve this one. You can also use that. I put the MATLAB command here. Let me see where I can put the C and the D. Sorry, this is final answer, right? Now this is previous one. This is this one. Then we have this one. Yeah, this one. This one you can write it as 32 and 8, 2 and 2. They are the coefficients of these two, right? Then inverse is MATLAB command. MATLAB. And this one, I say this is some W1. This is some W2 times W1, W2. That's it. You can run this. You can run this from MATLAB. You can find C and D. You will get the answer is a vector. Is a vector. This is C. This is D. Some value. Right? You can run this. Yeah. But if you have these in homework, you can use MATLAB like this to get this one. But in the exam, you have to calculate by your hand. And of course, at that time, I think I won't give you things with cube here. Maybe I put a square. Square things will tend to be better because you only have one letter. Here's a C and a D. Then you will only have like a C. You cannot solve from the special value. You need to solve equation that will be some number times C equal to another number. Then you just divide it. You can get it, right? Okay. This is example 3. We have time, right? 41. Okay, now we check another example. Example 4. G of S which equal to, okay, yeah, here's a 2 plus S. I still use 2 plus S. And here's S times, I use this one, S squared plus 2S plus 16. I use this one. Then how to solve it? Of course, you need to check the table to see which terms will be useful. So here in the denominator, I have two factors. One is S, so we know, okay, you can use this one, right? The other one is S squared plus 2S plus 16. You can think like write this as this one actually equal to S plus 1 squared plus equal to negative 15, right? So S plus 1 equal to square root of 15 times J. J is the square root of negative 1. Sorry, the nose. Yeah, this one, this part, it is this one and this one. Then we have S equal to negative 1 plus or minus. Okay, it's a plus or minus. Square root of 15J. So this whole thing can be written as S minus this. So S plus 1 plus square root of 15J times S plus 1 minus square root 15J. You can write it in this way. Then you see the denominator, you have 3 factors. We can follow the previous method, separate as 3 parts. But now you have complex number. You have to handle some complex numbers. That makes things complex. Yes, they're complex. So here we can use the table directly. We have this term, you see. Yeah, we have this term. We have this one. Do we have more? Yeah, we have this one, you see. I have S times this one and S squared over it. So we can try to use this. Right, we can try to use this. Okay. Then remember, right? Remember, okay. Denominator is as same as here, but numerator is constant. Do we have constant with S term? Yeah, S can be cancelled with that one, right? So okay, we can just use that. Let me copy. We have the term U term. I copied it from the to the notes. Okay, I have omega n squared over S times S squared plus 2 add omega n s plus omega n squared. We have this one. Now we go back to our notes. You compare, same denominator, but numerator different. We have two terms, so we need to rewrite it as similar as the first example, but just the longer denominator. So we have g of s equal to 2 over s squared plus 2s plus 16, and plus s over s squared plus 2s plus 16. Okay, these two can be cancelled, right? And here we need, you see, we need some omega n squared, zeta, omega. What are these? Okay, omega n squared is 16, right? This is 16. So omega n is 4. We just use positive number. Yeah. And here 2 eta omega n equal to 2, right? This is 2 eta omega n. This is 2. So this is equal to 2. So eta times omega n is 1. And omega n is 4. We get eta equal to 1 over 4. So we know what are these omega and eta. Then we can just copy it from the table. Copy it from the table. So by inverse Laplace transform, we have g of t equal to the first term. We need that table. Table is here. Oh, numerator should be omega n squared, but our numerator is not omega n squared. It is 2. Omega n squared should be 16. So okay, so here will be 1 over 8 times that 16, right? That's 16. I do more calculation. G of s is 1 over 8. Omega n is now is 4 squared, and s times s squared plus 2. Okay, just 2 eta omega n s plus omega n squared. Omega n is 4 and eta is 1/4. And second term, it is 1 over that. 1 over that. But actually we have this in the table. We also need which one? This one. You see, this one. We also need omega n squared in the numerator. Omega n squared in the numerator is 16. So here I also need a 16 in the front. It's omega n squared and s squared plus 2 eta omega n s plus omega n squared with same omega n and zeta. And in front, here's 1 over it. Now you put this is 4 squared, so you need another 4 squared in the denominator, right? 16, right? If they cancel, you get this one. So from here to here, they're exactly same, equally, right? Then just copy the table. 1/8 times, okay, let me copy the table. This one is a little bit longer, but just be patient. Omega n over 1, this one, I confused. This is 1/8 is the first one with a denominator with s terms in this one. Okay, it is, I copied already. It is 1 minus 1 over square root of 1 minus zeta squared e to the negative zeta omega n t sine of omega n square root of 1 minus zeta squared t plus zeta, and the zeta equal to cosine inverse of zeta. This is the first term. The second term is this one. So it's here. It is let me copy it first. It's omega n over 1 minus zeta squared times e to the negative zeta omega n t times the sine of omega n square root of 1 minus zeta squared t plus zeta. Zeta is the same. You see? Oh, no. This is no cosine zeta. This is a sine omega n square root of 1 minus times t. Okay, that's it. No zeta. Oh, if you divide by s, here you need to have a set. If you do not divide it, here no set. Okay, and the theta should be a value smaller than 1. Yeah, our theta is 1/4. It's smaller than 1, right? Yeah, we get and the coefficient here is 1/16. Almost done. I just leave it here. If you want thoroughly finish, you need to plug in omega n and zeta here. Yeah, you still have a lot of calculations, but you can finish, right? I just leave it here. Now you know the method here. I explained how to do it, right? And this one, of course, you need a calculator. Cosine inverse of 1/4, some value. You can find that value and put it here. All right. Okay, that's all for today, and see you next time. Actually, next time we'll go back to classroom. All right, so see you in the classroom, and have a good weekend. Bye bye.